Okay, so in this test 12K, we'll be doing these two questions, okay? And open your textbook to page 233. Let me read the question for us. Okay, first is 19, okay? A hot plate of an electric oven connected to a 220 volt line has two resistance coils, A and B, each 24 ohms resistance, which may be used separately, first case, and in series, second, and in parallel, third case. So what are the the currents in these three cases? So we have to do this in three cases, okay? So here, question number 19, page 233. So as we read the question just now, we see here that the potential difference or the voltage is 220 volts. This is nothing but, we call it as your voltage or your potential difference. Then let us put R. There are two resistances and each of them have a value of 24 ohms. Is resistance of resistance means resistance value of each of the two resistance coils, okay? Now let's start with the first case. The current flowing in the first case is what we have to find when the two coils are used separately, okay? So let me just fix this, okay? When the two coils are used separately according to the text language, when the two coils, resistance coils, are used separately, okay? So means individually, in other words. So in such a case, let us put here I1 be the current value that we need to calculate and find out. Now, so by Ohm's law, okay, by Ohm's law, because this is going to involve I, V and R, so obviously the only formula that relates it, V is equal to I to R, the Ohm's law, the famous Ohm's law, right? So V is equal to, in our case here, we're taking I as I1 into R, each of them separately, so only one, we have to take only one of them separately. In other words, the mean here is individually, singly, okay, in single. So that implies V, and if you were to bring this R, it will come down to the denominator, is equal to I1. We did that because the question is saying find the current, right? In each of these three cases, so I is the current which we want to find out. So we write here V is 220 volt, as we can see here, and R is, as we can see, just so up there, 24 ohms. This is the value of the I1, right? So we can write that as, if you want, you can bring it down to the left side if you want, equal to 220 divided by 24. And we know both these units are in SI units, so volt by ohms is nothing but ampere, the SI unit of current, I1 current. So 4 seems to be going, 4 6 are 24, right? Then here 4 5s are 20, but 22 is there, means remainder 2, the 2 will go in front of the 0, so 24 5s are 20. So we have to now divide 55 by 6, which is 6 9s are 54, 1 remainder, and point means 1 0 will come, 6 1s are 6, 4 remainder, then point means again I can put a 0 here, 6 6 are 36, again 4 remainder, decimal means we are allowed to put 1 0, so 6 6 are 36 again. Like that we can go to the third place of decimal, which is the normal way of doing, and even the textbook is doing that. In this case I think 9.166 ampere. We went to the third place, that is the normal way of doing, because answers are expressed usually up to second place. This is after point on the right side, It's called first place, second, and third place. So if third place is 5 or more than 5, in this case more than 5, 6, then the preceding digit will increase by 1, which is 6. So 6 plus 1, 7. So the value of current flowing in the first case when one coil is used separately is around 9.17 ampere. Our first answer. Okay, so that's your first answer. And the second case, I'll just do like that. In the second case, look into your textbook. These two coils are used in series. So when they are in series, the two coils, how much would the current flow? So let us do that. So when the two coils are in series, let us assume that let I2 be the value of the current, which we don't know yet, and let RS be the total resistance of the two coils. Total resistance of the two coils, let us mention in series. Clearly second case is series. If you are in series, the total, which is RS, will use the series formula, first plus second. Each of them have same value, 24 ohms. Two of them means first one plus second one, which is simply 24 ohms plus 24 ohms, which is 48 ohms when we add 24 plus 24. So we found this RS, R is there, I2 we have to find V is there. Just like we did a moment ago for the first case, we can now use the Ohm's law. So by Ohm's law or using Ohm's law, whatever you like to write, the way you want to write, it's up to you. V is equal to I, in this case I2, into R, total RS, because now they're in series, the two are combined, so we need to use RS, not R. They're not used individually anymore like the first case. They're combined in series, so combined value total. So as they're saying, find the current in each case, so I2 is the current, we keep that alone and shift this RS, then it will come to denominator. So V is 220 volt divided by, as you can see here, RS value total 48 ohms. This is I2. So I2 will therefore be 220 by 48 ampere, because we know volt by ohms is ampere, the SI unit of current. 6 seem to be going again. 6 8s are 48. 6. Also 4. Let's do it for 4. 1s are 4. 4 2s are 8. 5s are 20. 2 in hand. 4 5s are 20. So 55 divided by 12 seems to be our current. So 5 60. So 4s are 48. Then 50 minus 8 is 15 minus 8 is 7. That's all. The remainder, then 0.0. 12 5s are 60. Then here 10 remainder. Point means one more 0. 12. 84, 94. 8 is going in thing. 8. 4.58. Let's write it this way. 4.5. 8 2s are 16. 8 1s are 8. 9. So 4 remainder. 0. 12 3s are 36. Like that we can go up to the third place of decimal. So since we have reached third place, you can stop there. So the approximate value of this I2 value is 55 divided by 12, as you can see here, 4.583 ampere. Okay, then that will be 4.5. Third place is now less than 5, so this preceding second place, preceding means the one in front, second place of decimal 8 will not change, remain same. So approximately in the second case, 4.58 ampere is flowing when the two coils are connected in series. Okay, so last in this question, the third case. Okay, Okay, so we can just, now they are in parallel. When they are in parallel, what is the current? So let I, we can just use the same one, I think, 3 be the current, and then RP, because they are now in parallel, let's just use the notation RP be the total resistance. Be the total resistance of the two coils, this time in clearly in parallel, so we write here parallel. So up to here you can write that way. Okay, now parallel, calculate the total resistance in parallel is different. We know that, we've discussed this in the previous. So reciprocal of total 1 by RP will be reciprocal of the first one plus reciprocal of the second one, 1 by first, both of them are R and R, so 1 by R plus 1 by R. So that implies 1 by RP is equal to, you can do like this also, 1 by X plus 1 by X, we know is 2 of them are there, so 2 into 1 by X. Similarly, 1 by R plus 1 by R, we can write 2 into, to make it simpler for us. Okay, then we can proceed and do, so that implies 1 by RP is equal to 2 into 1 by R, means here value is 24 ohms. 24 ohms, so this dot means into, so 2 ones are 2, 2 into 12, 24. Now we can cross multiply, RP into 1 is RP equal to 12 ones are 12, and this ohms also. So the total resistance is 12 when the two are in parallel. So we need to find I. The value we have here is RP, I3 and V is already there, so we can use Ohm's law just like the previous two cases by Ohm's law. V is equal to, in this case I is I3, as we can see here, into total resistance in parallel resistance, so RP. Just a matter of writing here, I3 don't move, then V divided by this RP will come down. So here V is 220 volt, as we can see here by RP value here 12 ohms is equal to I3. So we may as well write, if you want more comfortable, I3 is equal to then 220 divided by 12, and volt by ohms, SI unit of current, ampere. 4 is going, I think, so 4 3s are 12, 4 5s are 20, 2 4 5s are 20. 55 divided by 3 is our answer, so 3 ones are 3, 2 in hand. Bring down this 5, 25, 3 8s are 24, 1 in hand, then 0.0. I hope you're getting right. And 3 3s are 9. 1 remains 0 for this point, then 3 3s are 9. 1 more, then here 3 3 up to third place, we can go like that. 18.333 is what we're getting, 18.333. So we can write here equal to 18.333 ampere is our answer, which we can finally write it down as 18.33 ampere, because the third place is less than 5, so second place will not change. Okay, so that's your first question. Let us go to 20. One more question before we complete this test part. Okay, so question number 20. It's on the same page, 233. Let me read the question for us. Compare the power used in 2 ohm resistor in each of the following circuits. Number 1. Let's start with the 1. Here, as we read, let us see. a 6-volt battery in series with 1 ohm and 2 ohm resistor series. As we read, we know V is equal to 6 volt. Very clearly, the voltage involved in the first case. Then P1, let us put power. Calculate there. I think they're saying power in each case, so let us put P1 in the first case. This question mark is the power. Look into the language of the text used in the 2 ohm resistor. Power used in the 2 ohm resistor. Not both combined, but in the single one, 2 ohm one, not 1 ohm one also. So let us write here. Let RS be the total resistance of the, according to the question, 2 ohm, and one more is there, 1 ohm resistors, clearly in series. So if they are in series, their total RS will be first one 2 ohm plus second one 1 ohm, which is 2 plus 1, 3 ohm is the total resistance. So by Ohm's law, let's do that. Okay. So by Ohm's law, because that's the one that fits our purpose, I think, in this case. See here, V is there, R is there. So let us use Ohm's law to find the current. Okay, current has not been specified yet. So you can put here RS. So you just put your I. Let's use I1, right? I1 equal to question mark is the current flowing in this case. Let us put. So I, V and R. So V is equal to I1 into total RS. This is how we will get the I value, and we'll use that I to find the power P. Okay, so this one I1 will be V by RS. So V is 6 volt divided by RS is just now 3 ohms. As you can see here, RS is 3 ohms. So that will be 6 divided by 3. Volt by ohm is ampere. I1, so 3 twos are. So I1 value is 2 ampere. Clearly they are in series. Since current is same throughout the circuit in series, let's write that. So since current is same, okay, throughout the circuit, throughout the circuit, okay, throughout the circuit when they are in series, right? Okay, 1 minute. Throughout the circuit when they are in series, we have discussed this and learned before also. So in this case, because the current is same throughout the circuit in series, let's just write here. Already done. So I1 just now equal to 2 ampere is the current through, is the current that we calculated just now. See here, I1 through okay, let me write you both the 1 ohm and 2 ohm resistor. Since current flow is same everywhere in series, in parallel it's not. We have learned that before, right? See here, battery is here, and you know current flows from positive towards negative as it comes pass through first one and second one. No need to draw this. First one is given as 1 ohm, and the second one is giving us 2 ohms. Let us say current comes out here, I, 5 ampere. Then whatever 5 ampere is here has to pass through here and come out 5 ampere. And the same has to pass and come out. This is what we mean when current is same. Because there is only one path through which the total current will flow. So the current passing through 1 ohm resistor and the 2 ohm resistor is the same because they are in series. That's what we mean to say. Right, so here, because of this, we're now going to use the power equation. I think the power equations that we're using are P is equal to E by T, or W by T, and P is equal to V into I. Another one is P is equal to I square R. Another one is P is equal to V square by R. These are the 1, 2, 3, 4 famous power equations we have already memorized. Let us see which one will fit, because the question is saying find the power in each case. So here, I is there, right? Then R is also there. See, RS, 3 ohm. So we can use that. So let us use through the 2 ohm. So P1 is equal to, we're going to use this one, the one appropriate, I square R. In this case, I1 square. And the R we're going to use is, go back to question, see, power in the 2 ohm resistor. In both cases, we have to calculate the power through the 2 ohm resistor, not the both of them combined. So R in this case will be the not 1 ohm but the 2 ohm, because question clearly says find the power through the 2 ohm resistor, not both of them combined. So P is equal to I square R. We're using this. So I1 just got now found here 2 ampere into 2 ampere, because I square means twice we have to write. Here 2 ohms. 2 2s are 4, 4 2s are 8. Ampere into ohm, everything in SI. So SI unit of power is watt. So 8 watt is the power through the 2 ohm resistor. Okay, that's our answer. Now let us go to the next one in parallel, when they're in parallel. Okay, this one can be kept just for a reference for the time being, maybe. Okay, so here, I hope you've done right. Case 2, second case. Okay, second case is when they're in, let us read their number 2. Let me read once. Question number 20. A 4-volt battery now in parallel to 12 ohm and 2 ohm. So V2 here, as we read, the V is also changed, not 6 volt anymore. 4 volt is the voltage in the second case. So let us put this one as V2. Let us put P2 as the power, as the question mark, as the power. Look into your question. Power used in the 2 ohm resistor. Used in the 2 ohm resistor. Now, this is the one. Let us just put it here. I2, in this case, this is the current flowing. Okay, current. Now, let the 12 ohm and R in parallel. Let I2 be the current flowing through the 2 ohm resistor. Okay, I2 is the current flowing through the 2 ohm resistor. Okay, so this is the one. Okay, so by Ohm's law, to calculate this I2, let us use Ohm's law. By Ohm's law, V is equal to I into R. V2 is equal to I2 into the 2 ohm resistor. So the R in this case is 2 ohm. We have to be careful with that. Now we cannot use the total, because when they are in parallel, let me show you. positive and negative. Current flow through here. Let us say I, 5 ampere, come here, and there are two resistors. Look into the question. First one is 12 ohm and the second one is 2 ohm. So this total current 5 ampere, some will go through here, let us say 3 ampere, and here 2 ampere, something like this. Total of course will be same, 3 plus 2, 5. Some will flow through the first one, some will flow through the second resistor, unlike the in series where current is same because there's only one path. But here the current through first and second resistor will be different because they have additional paths, and some current will flow through first and some will flow through the remaining will flow through the other one, right? That's why they're clearly specifying current through the 2 ohm. That's why we're just written 2 ohm and not the total 12 and 2 together. Okay, so let us just remember that. And so how do you get this? That gives you V2 is here 4 volts is equal to I2, we don't know, so just keep it, and these 2 ohms we can shift it, then coming down, so that will give you 4 divided by 2. Volt by ohms is ampere, so this is I2, so 2 2s are 4. So current in the second case when they are in parallel is 2 ampere. Okay, now so current is this one. So since current flowing through the 2 ohm, current flowing through the other one 12 ohm, okay, 12 ohm will be I2 into here will be 12. So we have to find them separately. This is the difference between the first case and the second case. So now since power equation again, this one P2 is equal to I2 square into R. In the R in this case is the power through 2 ohm, so we have to just use 2 ohm only. So that will give you I2 is 2 ampere, as you can see here, into 2 ampere into here 2 ohms. 2 2s are 4, 4 2s are 8. Ampere into ohms is SI unit of power is watt. So even in the second case the power is the same, 8 watt. Okay, so that concludes the portion for 12K. Okay, as I said, in this second case, while calculating the current by using Ohm's law, we have to put the 2 ohm and not the other one 12 ohm because they are in parallel. Okay, because in parallel the current through first and the second one are not same, so we have to current through the 2 ohm we have to use 2 ohm, current through the 12 ohm we have to put the 12 ohm in the formula V is equal to I into R, the Ohm's law. I hope you're getting right. Okay.